Let's just wait a few minutes. Hopefully, some people will join.
Okay.
Okay, good morning, guys. Just a few minutes. I'm trying to send the summary of the circle theorems to my laptop. Just a moment. We'll start at 10 past. Oh, it's refusing to go through. Please indicate which grade you are in, just to make sure that we are mixed, or maybe we just one group. Then I'll just focus on one syllabus. If you are all in grade 12, for example, or then if there's grade 12 and 11, then I need to know. Then I know I need to cover from grade 11. Why is this thing not wanting to go through? Let's do it again. It's coming. All right. We will start now. You see your messages. Grade 11, grade 12, 11, okay. Okay, good morning. My name is Mapule Mulabi. Those who have not met me yet, but I'm seeing familiar names here. I'm the founder of Gr11&12. So today I'm offering this free lesson as the way to say thank you for those who have been with Gr11&12 for the past 2 years or for the past year or a few months. So this is just a token of appreciation. So we're gonna do Euclidean geometry. The scope that covers both 11 and 12. So we won't do the scope that is only grade 12, but we'll do the one that is both, which is the basic geometry, which does not include proportionality and the other section here. Right, so let us start. Apologies for starting late. I just wanted to give some few learners a chance to join us, just in case. Okay, right, so let me minimize this. Just open what I just saved, the summary of the theorems. Okay, let's see if we can zoom. Okay, so these are the theorems that you have. So I don't really want to go and prove them unless if someone would like me to prove them, please, you can just let me know. Unmute, don't send a message because when I'm busy, I don't see the inbox. So if you want me to go through proving a certain theorem, just unmute and ask me to do the theorem with you guys. But I don't want to do all of them because if I do the theorems or prove all the theorems, then our time is just going to be swallowed into that. into just proving the theorem instead of trying to solve the problems that you will get in the test or in the exam. Okay, so the first theorem, just go to my book. Okay, before we go into the first theorem, let's cover these basics. Okay, so in geometry, you've got angles that are on a straight line. So you'll have angle A1, 2, and 3. So we do know that angles on a straight line, they are supplementary. That means these angles, they will add up to 180 degrees. So when you see any angles, when you draw a line, it ends up, if you draw this angle, it ends on the same line. Those angles will be on the straight line. Unlike when I draw this, these two angles are not on the straight line because I don't end up on the same straight line. So your angles must be all on that, covered on the straight line. So the reason, because in geometry, you need to give a reason to everything. So this is angles on a straight line. That's the shortcut. And then we also have, if this is a point, angles around this point, they add up to 360. So if I have A1, 2, 3, 4, that means A1 plus A2 plus A3 plus A4, they're supposed to give us 360 degrees. And then we also have vertically opposite angles. So someone sitting across, right across you, like in class, the person sitting right across you, not the one on your side, the one either in front or at the back, that's your vertically opposite angles. So O1 and O3 are vertically opposite, but O1 and O4 are actually adjacent, which are the ones that form a straight line. Adjacent angles on a straight line, they're supplementary. So someone that is on your side, we refer to that as adjacent, but someone that is across or in front of you or at your back, that's vertically opposite. So vertically opposite angles are equal. That means O1 is O3, and then you see O2 and O4 are also vertically opposite. So O2 is O4. Just remember to put the caps. Yes, I'm not putting them because I'm in a rush. So those are vertically opposite. Then we've got parallel lines. So on your parallel lines, we've got three things that you can get when your lines are parallel. You get corresponding angles that are equal, which form an F shape. So you have corresponding angles, those form an F shape. So if I have line AB, CD, these angles inside this F shape will be equal. So if this is A1 and C1, that means A1 will be equals to C1. Also, sometimes in your test, they will give you maybe a picture like this, but they say to you, they showed to you these arrows. These arrows, they mean that the lines are parallel, right? So another thing, if I say A1 is C1, remember you have to give a reason for everything you say in geometry. So you say here corresponding angles are equal, and then you tell them for which lines. AB is parallel to CD. So you have to mention the lines that are parallel that are giving that corresponding angle. Also, can you see that this is also an F shape going backwards? So that means B1 and D1 will also be equal. So you can get different pairs of angles that are equal on the same parallel lines. As long as you just check the shape, the F can be looking backwards, the other one can be looking forward. So as long as, but they must be within the parallel lines. Okay, so that is the corresponding. Then we also have alternate angles that are equal. These are angles that form a Z shape, that are from a Z shape. So if we have these lines that are parallel, so if I have these lines that are parallel, A, B, C, D, okay? So you can see I have two Z shape. The first Z is this one, right? And the angles that are inside that Z is this one. So from that Z, angle A is equal to angle D. But there's also a Z looking this way. And the angle inside this Z, angle B, will be equals to angle C. Then don't forget to give a reason. Your reason will be alternate angles are equal, and because line AB is parallel to CD. So that's the Z shape. And then we have the co-interior angles. So co-interior angles is the one that form a U shape. So co-interior angles, they form a U shape. So if you look here, you can also get a U here. Okay, so angles inside this U, they are supplementary. Supplementary, it means the angles add up to 180. So if I have EF here, so 1 and 2, and then that's F1, that means E1 plus F1 will give me 180 degrees. The angle will, the reason will be co-interior angles equal, because line, let's say this is E, B, and C, because line EB is parallel to CF. Okay, so please guys, where I'm making a mistake, please correct me, because I am not a math guru, so I do make a mistake. So don't let me carry on with a mistake. So where I make a mistake, please indicate, then we correct it. So we don't carry on with doing something wrong just because the tutor is saying so. Okay, so those are the parallel lines. So when they give you that question in a test or in an exam, when they mention that certain lines are parallel, look out for these three things. Check which shape do you see. Do you see an F? If you see an F, check which angles you can say they're equal. Do you see a Z? Check which angles can be equal from that Z. If you see a U normally you can resort to it. If you don't see an F and you don't see a Z, then you can go and use a U, but we don't normally use the co-interior. But when you don't have any other choice, if you don't see corresponding angles, if you don't see alternate, that means the only thing you're gonna use is corresponding. But otherwise, if there's an F, you see a corresponding, it's similar to the, a co-interior is similar to corresponding. So if you have an F shape, you don't really need to use the co-interior, the U shape. But in the absence of the corresponding and the alternate, your only option left is the co-interior angles. Okay, so that is that. Then we've got triangles. So angles, the interior angles of a triangle are supplementary. That means, remember, supplementary means angles, they add up to 180. That means angle A plus B plus C, they add up to 180. So that's the angles. The reason will be angles of a triangle. Okay, so this angle, that angle plus that one, they add up to 180. And then now you have exterior angles of a triangle. So when you've got a triangle like this and there's an exterior angle on it, then this exterior angle is equal to the sum of the interior opposite angles. So if this is C1 and 2, that means C2, which is an exterior angle, will be equal to the sum of those two. So C2 will be angle A plus angle B. Your reason would be, someone is not muted, please mute. Exterior angles of a triangle. Okay, so that's the exterior. So when you've got a complicated sketch, there are triangles, just try and look, do you see any exterior angle? And also remember that an exterior angle, it has to be an angle on the line that is extended from a triangle. You can't tell me that this is an exterior angle. It can be, okay? Your exterior angles will be it forms on the same line that is coming from the same triangle. So that's an exterior angle. This will be an exterior angle. Okay, so don't make that mistake. Then we have equilateral triangle. Equilateral triangle. In an equilateral triangle, all sides are equal and all angles are equals to 60. So all sides are equal. So that means side AB is equal to side BC is equal to side AC, but also all their angles are equal. Angle B, okay, they're equal. But also these angles are equals to what? They are equals to 60. Those that don't know why they are equals to 60, remember we say all angles are equal. Also we said angles of a triangle are supplementary, which means they add up to 180. So if all angles are equal, that means we can say these angles are all A's. Now we have 3A is 180. That means A is 180 divided by 3, which gives you 60 degrees. So in an equilateral triangle, all sides are equal and all angles are equal to 60 degrees. Okay, so that's that. Then we've got an isosceles triangle. Isosceles triangle is a triangle with two sides that are equal. So this side is equal to that. So angles opposite equal sides are equal. Sides opposite equal angles are equal. So if you've got two sides that are equal, that are opposite, that means their opposite angles are also equal. So if AB is equal to AC, that means therefore angle B will also be equal to angle C. The same way, if they tell you that the angles are equal, if they tell you this and this are equal, therefore, so if this is ABC, they tell you that angle B and C are equal. Therefore, you can conclude that that means even their sides are equal. And the reason here you're going to say opposite sides equal opposite angles. That's the shortcut. So if the opposite sides are equal, their angles will be equal. If the opposite angles are equal, their sides will also be equal. Okay, so that's just the basics on that part. Then we also have concurrency. So concurrency has 4 options. If they ask you to prove that triangles are congruent, you can either prove them by 3 options, where now your corresponding, remember corresponding is like the one that is similar to that or on the same side. So corresponding side on these 2 triangles, this one is correspond to this correspond to that one, this correspond to this. So all corresponding sides. So this is the side, side, side. So if you can prove that all the 3 sides on the 2 triangles are equal, therefore those 2 triangles are congruent. Or if you've got 2 corresponding sides that are equal, right? And an included angle. So the angle, included angle is the angle that is between those 2 corresponding sides, those 2 sides that are equal. Therefore, you will have a side angle and a side. It doesn't matter how you write it. You can say side, side angle or angle, side, side, but it's the same thing. So if you can prove that between the 2 triangles, 2 corresponding sides are equal and the included angle is also equal, therefore those triangles are congruent. Then condition 3 is when now we've got a angle, angle, side. So you've got 2 angle, corresponding angle. This angle is equal to that. This one is equal to that one, and another side, but corresponding side. So here you have angle, side, angle, or you can say angle, angle, side, or side, angle, angle. So if you find that 2 corresponding angles are equal and the other corresponding side is equal, therefore the triangles are congruent. Then the last one is right angled hypotenuse side. So right angled hypotenuse side. So you find that the 2 triangles have a right angle, okay? They also have the hypotenuse sides that are equal, and then one other side. Therefore, the triangles will be congruent, and this is the symbol for congruency. Okay, so I'm just going quickly through that. Then we're gonna go into the theorems. Okay, then on geometry, you've got a circle, and this is a circumference. So circumference is like the boundary, which is more like a perimeter on a rectangle or a triangle or a square shape. So a perimeter on a circular shape is called a circumference. So this is the circumference. This is the circle center. Okay. And then a line drawn from the center to the circumference of the circle is called a radius. Okay. So this radius, it can be drawn anyway. That is a radius. That's a radius. As long as it's drawn from the center to the circumference. So it doesn't matter where it's looking at. Okay. So that's that. Then a line joining 2 points and passing through the circle center is a diameter. So that straight line joining the 2 points on the circumference, that is a diameter. And that diameter can be facing anywhere as long as it cuts through the circle center. That's a diameter. That's a diameter. That's a diameter. So any line joining 2 points on the circumference but passing through the circle center. Okay. But now we have another line joining 2 points on the circumference, but it does not pass through the circle center. That's a chord. And then when that chord cuts the circle, you will have an arc here. And this is a minor arc, a smaller arc. And then this is the major arc. This is a major arc. Okay. And then also where we have cut that, this section is a minor segment. That portion is a minor segment. And then the bigger portion is a major segment. Major meaning the bigger part of it. So that's the major segment. Okay, then the last thing is a tangent. A tangent is a line drawn from outside of the circle, touching the circle at only 1 point. That's a tangent. Okay. So before I forget something, so a tangent is always perpendicular to a radius, always. A tangent is always perpendicular to a radius. So wherever they tell you this is a tangent and there is a radius, then just know that that angle between these two things will be 90 degrees. Okay. And then that's that part. Then the other thing before I go into the theorems, remember a quadrilateral is just any four-sided shape, right? Any closed four-sided shape. So a quadrilateral, angles of a quad, they add up to 360. So angle A plus B plus C plus D, they add up to 360 degrees. Those are angles of a quad. Okay, so that is that. Then I'm just trying to remember the other things that they don't write, but we need. And then also so if this is a quad, and then these points of these points lie on a circle, right? So if these 4 points of a quad, remember a quad needs to have only 4 sides. So if those 4 points lie on a circle, that makes it a cyclic quadrilateral. Quadrilateral. Okay. Okay, the spelling, never mind the spelling. So if they tell you that points A, B, C, and D lie on the circle, that means that A, B, C, D is a cyclic quad. But sometimes they give you more than 4 points. Maybe there's point E here. It also lies on that. But maybe the sketch goes like this. That's a F. But they've told you that all this point A, B, F, C, D, E are the points on the circle. That means what you will take out of there is that if you look here, this is a four-sided shape, and the vertices, which are the corners of that four-sided shape, they lie on the circle. That means this ABFE, it's a cyclic quad. And then also ABCD, it's a cyclic quad because the four corners of that lie on the circle. Okay, so you can take out a four-sided shape, then that will be a cyclic quad. Then you will know that the theorems on a cyclic quad, if you have a cyclic quad, opposite angles, interior opposite angles of a cyclic quad, they add up to 180. Exterior angle of a cyclic quad is equal to the interior opposite angle, and also angles on the same side are equal, but we'll just go into that just now. Okay. Anyone having any questions? Now we can look at the theorems. Okay, so I'm not gonna prove them, but we're just gonna quickly just read through them. So theorem 1, it says the line drawn from the center of a circle perpendicular to a chord. So you have a circle and a center, and then you have a chord. That's called AB. So they say a line drawn from the center of the circle perpendicular. Perpendicular meaning they form a 90 degrees. So that's O, that's C. So you are given a circle with center O and then a chord AB. And this line is perpendicular to that. So you are given that OC is perpendicular to AB. And wherever you see a sketch like this, where the line from the center, it goes to a chord and it makes a 90 degrees. That means it bisects that, because the theorem says a line drawn from the center of the circle perpendicular to a chord bisects the chord. Bisect meaning it divides it into two equal parts or pieces. That means AC is equal to CB. So the minute you see this, a line from the center to a chord with a 90 degree, then just already know that those two sides are equal. So take that and put it down, okay? Or theorem, a converse of this theorem. Now they tell you that a line drawn from the center of the chord to the midpoint of, the line drawn from the center of the circle to the midpoint of the chord. A midpoint is the center, right? If this is the midpoint, that means this already they are equal. So you are given that AC is equal to CB. If AC is equal to CB, right? Because that line from the center is at the midpoint. Therefore, OC will be perpendicular to AB. That's the converse for theorem 1. Okay. So like I said, if you have a question, please just unmute and shout. I will attend to you. Then we can clear whatever you need to clear. On every theorem, so you are given this information, but you see this shape, this is not a triangle. This is not a quad. This is nothing. That shape, you can't do anything. So for you to prove, you always need to construct a radius. Sometimes you need to even extend it. On certain theorems, you need to extend it. So you extend the radius, then you see now you've got two triangles. And if you have two triangles, and then you will be required to prove that, let's say it was the first theorem, you are required to prove that side AC is equal to side BC. You see, those are the two corresponding sides on two triangles. That means you can use concurrency. And with concurrency, you just need to prove it using one condition. Therefore, the rest will be equal. So if you find that in two triangles, let's use this one. You find that in these two triangles, you find that this side is equal to that. Can you see this is a radius? Because it's a line drawn from the center to the circle, circumference of the circle. This is also a radius. Therefore, OA is equal to OB. So I might as well prove this. So the reason will be radii, because those are they are radiuses. Okay. Then, so if you are proving your theorems, the first thing you need to construct your radius. Sometimes you even need to extend that radius further. After constructing that, you compare, you see, then when you've got two triangles, there are two things you need to first check. The first thing, check if you don't have radiuses there that will be equal. If there's a radius on a radius is the same everywhere. As long as it's in the same circle, they are equal. Also check if you don't have a common side. A common side is like the wall you share with your neighbors. This is a common side. This wall belongs to this triangle, but it also belongs to that one. So OC is OC on the two triangles. So this will be triangle AOC and triangle BOC. So OC is a common side. Okay. Sometimes you have a common angle. So if you look here, can you see this angle belongs to the big triangle? And the very same angle belongs to the small triangle. That's a common angle. So there's a common angle, a common side. So you look for a common side to this side. Then now you need to get the third thing. Okay, we have those. Then what else can you get? They told you that these are perpendicular on theorem 1. A line drawn from the center to the chord. A line drawn from the center perpendicular to a chord. So you were given that OC is perpendicular. That means now C1 is equals to C2, which are both equals to 90 degrees. So you see now you've got a side, and an angle. You don't have to write this when you write your thing. Therefore, you can say that triangle AOC is congruent to triangle BOC, and you give your reasons because you've got a side, and a corresponding side, and a corresponding angle that are equal. Then once you have proven that, right? Once you say that the triangles are congruent, that means the remaining sides are all equal, all the other angles are equal. Then you can also, then here you will say AC is equals to CB, which is the proof that you were required to prove. But also that means that angle A will be equal to angle B because the triangles are congruent. And also angle AOC will be equal to angle BOC. Because once you've proven that triangles are congruent, that means all their angles are equal, all their corresponding sides are equal. So that's that, okay? So that's a theorem 1 and its converse. Then let's move on. So let's do an example quickly. So you are given this. In the diagram below, O is the center, okay? The minute they tell you there's a center, look out for a radius or a diameter, okay? Then you've got this chord, you've got this chord. F, C, D, A, E, B, 1 and 2. Okay, then those lines, they means they are equal, right? Sorry. So they say AE, O is the center, and you are given that AE is equals to EB. You're also given that OE is 3 centimeters. You're also given that AB is 8 centimeters. And they say if OF is 4 centimeters, right? Somewhere on my laptop I can't write, so just bear with me. Then they say determine the length of chord CD. That's what you are looking for, okay? So they told us OF is 4 centimeters. They told us AB, which is the whole thing, is 8. And then because they said AE is EB, that means this is a 4 and a 4. They also told us that OE is a 3. Okay, so that's the information they gave us. So what you need to do when you are given something like this, you need to ask yourself, which theorem am I seeing? Okay, so if we focus on the left-hand side, I'm seeing converse of theorem 1. Converse of theorem 1 says a line drawn from the center of the circle to the midpoint, because if they say this is equal to that, that means this is the midpoint. To the midpoint of the chord, it is perpendicular. That means E1 is equals to E2, which is equals to 90 degrees, because a line drawn from center to midpoint. So that's that one. So if this angle now is 90 degrees, now when you have 90 degrees, you can use a Pythagoras. You see that's 90, you are given EO, you also know AE. So you can get this longer side, OA, by using a Pythagoras. So OA squared is AE squared plus EO squared. OA, we don't know. AE is a 4, EO is a 3. So that's a 16 and a 9, that's 25. Therefore, we square it both sides, OA gives us a 5 centimeters. So this is a 5 centimeters. But what is the OE? Can you see OE is a line drawn from the center to the circumference? That's a radius. And how many radiuses can you guys see here? There's another line drawn from the center to the circumference. So that means OA is also equals to OD, which is 5 centimeters. That means even here I have 5 centimeters. Okay. Now, when I come to the right-hand side of this, can you see what is this? Can you see this is Theorem 1, a line drawn from the center perpendicular to a chord, because that's a 90 degrees. That what means perpendicular. Okay. That means now we're going to apply Theorem 1. And it says if a line is drawn from the center perpendicular to a chord, it bisects it. That means this is equals to that. So that means CF is equals to FD, because line drawn from center. Yes?
Reasons. Don't we write reasons?
Yes, we write the reason. Where did I not put the reason? Here. Okay. Here is Pythagoras. Here, I'm trying to write the reason that F, okay, here is a radius, sorry. Then CF is FD. I'm trying to write the reason there. A line drawn from the center perpendicular to a chord. Right? Okay, then that CF is FD. But also, they want CD. Can you see CD is this big line? But for us to get a CD, we need to get these smaller portions. So from the information we have already, you see we have a 4, we have a 5, we have a 90 degrees. That means we can apply Pythagoras. So OD squared is OF squared plus FD squared. OD, we know it's a 5. OF, we are given is a 4. And then FD is what we're looking for at the moment. So that means this is 25 minus 16 is your FD squared, which is a 9. Therefore, FD is, it's a 3 centimeters. So this is a 3. So if FD is a 3, but we said FD is CF, therefore, we know that CF is FD, which will be 3 centimeters also. So this is 3. So now we know CF is 3, FD is 3. They want CD. CD, you see, is there when you add the two sides. CD is CF plus FD, which is 3 plus 3. That is a 6 centimeters. Anyone have a question or anyone confused? Please ask now. Right. Okay. So I'll assume you guys are fine. Okay. So that's that one. Let's move on. Theorem 3. It says angle at the center is twice the angle at the circumference. So Theorem 3 can be given to you in 3 different layouts. Okay. So angle at the center. So you will have an arc AB here. Arc AB. Arc AB. Okay. So this arc is just like some 2 points maybe on your roof, or you have a rod and then you are hanging something on that. So you've got 2, let me just see. So you have a rod like this and you are hanging maybe a loop or something. So you join a string this side, you join a string this side. This is your arc, or this is your chord. So then they will say the angle is subtended. So subtending is just like you're hanging something from there. So it's coming this way. So you are given an angle subtended by an arc. We said this is an arc. Okay. So this is an arc. This is an arc. So angle with the center, angle subtended by an arc. So this arc is hanging that lamp, right? Which is at the center. Okay, so it's hanging this angle. Then the very same arc is hanging another angle at the circumference of the circle. So there is the other angle hanging from the same arc or from the same rod. Okay, same this side. So that arc is hanging this and is also hanging. So we'll use this one at the bottom, not the one at the top. Okay. So we use this one. So this arc is hanging this at the center, and the very same arc is hanging this lamp at the circumference. Okay. So that angle is hanging from the same rope or the same rod. Okay. So same this side. That rope forms an angle at the center. The very same rope forms another angle at the circumference. So this is O, this is P. Okay, that's a P, that's a P. Okay, so the theorem says the angle subtended by an arc at the center of a circle is double. So you are given that you are given a circle with center O, right? And you are given an arc AB that subtend angle AOE, AOB, that's a B, at the center, and it subtend APB at the circumference. So this is applicable to all these diagrams. So you are given the circle with center O, you're also given this arc that subtend these two angles. One is at the center, the other one is at the circumference. Then they say this angle subtended by an arc at the center of a circle is double. So they say this angle, you are required to prove that the angle at the center is twice the one at the circumference. I said to you, for every proof, you need to always construct something, which is most of the time it's a radius. Sometimes you need to extend it, because look at this shape. That shape we can't recognize. We don't know what shape is that, so we can't work with it. So we need to have a triangle or something that we are familiar with. We construct that radius, OP, and extend it in this case. So you construct radius OP and then extend it. Construct radius OP and then extend it. So that's the same thing. Sometimes they can give you this sketch in an exam, and I expect you to do the proof. You must still be able to do it the same way if they give you this one. Okay, so you construct that, then you can say this is P1 and P2, O1 and O2, same this side, 1 and 2, 1 and 2. You can say this is a 1, and then the bigger one is a 2, that's a 1, that's a 2. Okay, so after you construct now, can you see, if we focus on the first sketch, you have two triangles, and can you also see these triangles? If this line extend, can you see when you extend the line on triangle, you form an exterior angle of a triangle. So if I extend this line, you see it formed an exterior angle of a triangle. This is an exterior. And we said exterior angle of a triangle is equal to the interior, sum of the interior opposite angles. So O1, that's the exterior, that's the interior, opposite. So O1 is equals to angle A plus angle P. Your reason will be exterior angle of a triangle. Okay. Can you also see from the very same line that was extended, it forms an exterior for the other triangle. So O2 is angle B plus angle P2. This is a 1. Okay. So, but you also know that what is a radius? A radius is a line drawn from the center of the circle to the circumference. A radius is a line drawn from the center to the circumference. You see those two lines are equal. So AO is equals to OP. These are radius. Okay. And then remember isosceles, if this line is equal to that in that triangle, that means their opposite angles are also equal. That means angle A is equal to angle P1 because opposite sides equal opposite angles. The same when you look on the right-hand side, you see this is a radius and this is a radius. They are on the same triangle. So this line is equal to that one. That means now OB is equal to OP. That's radii. Therefore, from that information, we can conclude that B is equal to P2. Okay, but we take this information, we plug it back into those equations we first got. We said O1 is A plus P1. That means, but A is what? Is P1. We did that. That means now we have P1 and P1. That means O1 is 2P1. Also, O2 we said is B plus P2, but we said B is P2. So this is P2 plus P2. That gives you 2P2. Okay. What are they asking us to prove? Prove that angle at the center. What is the angle at the center? AOB. What is this angle at the center? That's the angle at the center. Can you see is this one? It's actually sum of the two angles. It was split into two angles, O1 and O2, not A. O1 and O2. Okay, that's the angle at the center. What is O1? Here we got O1. Is 2P1. What is O2? There is O2, which is 2P2. If we take out the common factor as a 2, then we have P1 is a 2 into P1 plus P2. What is P1 plus P2? Look on the sketch. Can you see? P1 plus P2 is actually angle APB. So this is 2 of angle APB. Can you see? This proves the theorem. Okay. So that is that. So now the same applies. So if you check on this, the third sketch, right? You see what is angle AOB? This angle. You see that angle is P is O2 minus O1. Then O2 it was 2P2 and then O1 was 2P1. So you take that out, P2 minus P1. And what is P2 minus P1? There is P2 minus P1. It was this angle minus that one. So this is 2 angle APB, which proves the theorem. So whichever they do. So you see, only from here, when you're concluding, you can apply any other sketch you choose. Then the important thing also is that, remember the angle at the center, right? They must not be facing each other. So angle at the center is equal to angle at the circumference. Please don't say angle at the center is twice angle at that. Okay, it needs to be, it can't be facing it. Okay. So if I had another angle subtended by that very same arc, okay, I'm not drawing properly. So then that means here, I can say this one is twice this one. And then this one is the one that will be twice that one at the top. Okay. So that is that part. Then I'm gonna move. I'm not gonna do an example. Then angles on the same segment, angle in same segment are equal. So this theorem 4 says the angles subtended by a chord of a circle on the same side of the chord are equal. So you are given a circle with the center O, and then these angles, these points are on the circle. So you've got point A, point P, point Q, and point B. A, P, Q, and B. So you are given A, B, P, and Q are points on the circumference because they say angles subtended by a chord of a circle on the same side are equal. So you are given those points in the center, right? Then you are required to prove. So with that, we can just join this shape. Okay, that's your Q. That's that. They are not passing through the center. Okay, so that's that. That's that. No, not yet. So we just join these 4 points. Okay, so you have those points, right? There's one missing this side. Okay, so angles subtended by the chord of the circle. Can you see those angles? This is the chord, right? Or the arc. So angles subtended by the same chord. You see this very same arc or chord, it subtend this one. It also subtend that one. Same this side. It subtend that. It also subtend that. Same chord. Okay. So that's what you are given. Then you are required to prove that those angles that are subtended, they are equal. So they call them 1 and Q1, P1 and Q1. Okay. So like I said, look at the shape. There's nothing you can get because it's not a triangle, it's not a quadrilateral, it's not a circle, it's nothing. That shape that crosses, it's even the triangles that are formed there, you can't do anything because they're not even a right angle. So you need to do a construction. We said you construct a radius always. Okay, construct radius OA and OB. OA and OB. Okay. Okay. So now we have the radius. Then you see now after constructing those radius, can you see after the construction of the radius, I formed an angle at the center. Can you see that? So that's the angle at the center. And then can you already see a previous theorem we did? Can you see we have an angle at the center. We also have an angle at the circumference. You apply the previous theorem. So can you see that AOB is equals to 2 angle Q1? Because angle at center is twice angle at circumference. Also, can you see that angle AOB is also twice P1 because P1 is also at the circumference with the very same, subtended by the very same arc AB. Same reason. Angle at center is twice angle at circumference. Okay. Sorry. Right. So that's that. Then what are they looking for? Can you see AOB, AOB? Those angles are equal. If there's the same angle, that means 2Q1 is equal to 2P1. And if we divide by 2, the 2 cancels out. Therefore, Q1 is P1. That is exactly what you were proving on the theorem 4. These angles that are on the same side, subtended by the same arc, are equal. Same thing this side. So they can just give you whichever sketch. Okay, so that's a theorem 4. And also this, if you are given the converse for this, is that if they tell you that P1 is equals to Q1, if the angles on the same side are equal, therefore that AB QP is a cyclic quadrilateral. So the reason on this one, you say angles in same segment. Same segment, remember, is on the same portion of the circle. So they're on the same side. So here, if you see that the angles on the same side are equal, therefore, it's a cyclic quad. Okay, so while I'm on this, I'll come back to this point. So now that takes me to cyclic quadrilateral. When you are asked to prove that something is a cyclic cyclic quadrilateral. Okay, there are three conditions. The first one is when you have angles subtended by the same chord on the same side. Can you see those angles are on the same side? That means, so if this is P and Q, if P1 is equal to Q1, therefore this ABPQ is a cyclic quad. It's a cyclic quad. That's the first one. The second one, exterior angles of a cyclic quad is equal to the interior opposite angle. So you have a four-sided shape, and then on that four-sided shape, you've got this C1, and then A, B, C, D. So that angle C1 is equal to angle A. That's exterior angle of a cyclic quad is equals to interior opposite angle. So opposite, remember, opposite is directly, not adjacent. Don't say that, don't say B is opposite. That's adjacent. Okay. So a opposite will be across. So A will be C. So if I have a line this side, and then this is B1 and 2, then B1 will be equal to angle D, because that's the one that is directly opposite. Okay. Same if I have this side, that's your, that means A1 will be C2. That's your exterior angle and the interior opposite. So it doesn't matter where your exterior angle is coming from. Just make sure it's the one directly across. Okay, so that's the condition 2. Then we've got condition 3 for the cyclic quad. Opposite angles of a cyclic quad are supplementary. Okay, so you've got a if you can prove that these angles, when you add them up, they give you 180. Therefore, this will be a cyclic quadrilateral. Okay, so if A plus C is 180 degrees, then this will be a cyclic quad. Or if you find that B plus D is 180 degrees, therefore, it's a cyclic quad. So ABCD will be a cyclic quad. We can try to prove this one quickly. So you are given a ABCD as a quadrilateral. So you'll be given, that's theorem 5. You are given ABCD is a quadrilateral, right? You want to know if it's, you prove that it's a cyclic quad. So remember, I said earlier when we started that angles in a cyclic quad, they need to add up to 360. So A plus B plus C plus D, they need to add up to 360. These are angles of a quadrilateral. Okay. Then, like I said, this is just a statement that I was not supposed to put here yet. So you are given this. What are you required to prove? You are required to prove that A plus C and B plus D, they're both equals to 180, right? Then what do? You need to, like we said first, you need to construct a radius. Construct this OD, construct a OB, right? Now, can you see immediately after you construct, there's an angle at the center that is formed. And can you see that angle at the center is equals to double of that. So O, this is 1 and 2, O1 is 2A, okay? Then O2, this one, it will be double of this. So O2 is 2 of angle C. But if you look at angle O1 and O2, those are angles around the point. So O1 plus O2 is 360 degrees, angles around a point, okay? So, but what is O1? O1 we said is 2A, O2 we said is 2C, which is 180. We take out the 2, we have A plus C, which is 180. Then if we divide both sides by 2, therefore A plus C becomes, this is a 360. Why did I change? 360. So divide both sides by 2, then I get 180 degrees. You see now I've proven the first one. Okay. Then we still need to prove one more, but we said angles in a quad, they add up to 360, okay? Angles of a quadrilateral. So A plus B, so we can, but we said A plus C is 180, so we can arrange them like that, B plus D, which is 360. These two we have already proven is 180, plus B plus D, which is 360 degrees. I take this 180 to that side. Therefore, can you see B plus D is giving us what? 180 degrees. We've proven the second point. Therefore, that ABCD is a cyclic quadrilateral. So if they ask you to prove that a certain shape is a cyclic quad, first one, check if these angles are not equal, or check if those ones are not equal. If you find that angles on the same side are equal, therefore the cyclic quad. Otherwise, check if exterior angle is not equals to the interior opposite angle of a quad, okay? And then the last one, check if these angles, when you add them, they don't give you 180, okay? Then, therefore, that's you proving a cyclic quad. So that is that one. Before I go to a tangent, there is one more thing that is important. If you have a circle with the center, this is a radius, that's a radius, okay? But that doesn't matter in this case. But you've got these triangles here, you've got this. You are told that this chord is equal to that. So equal chords or equal arcs subtend equal angles. So you see this chord subtend this angle, right? And this chord, which is equal to that, subtend this one. So those angles will be equal. So equal chords subtend equal angles at the center of the circle, okay? So vice versa, if they tell you that this angle is equal to that, therefore this will be equal to that, okay? It's not a theorem, but it's just one of the things that you might need to use, okay? Also, angle subtended by a diameter. If this is a center and this is a diameter, the angle subtended by this diameter on the circumference is a 90 degree. So this must be a diameter for that angle to be 90, okay? So that's angle in a semicircle. Semicircle is half. That's how you reason up if you decide well, that D is 90. So every time, if ever they mention on a statement when you answering a problem, they say this is a diameter, look out for the 90. There must be, there's a reason why they always tell you something. If they tell you something is a diameter, that means you must pick out the 90 that they're not showing, but they're telling you indirectly by saying this is a diameter, okay? So even this, see this angle is at the circumference subtended by that diameter, it will form a 90. But please don't say this is a 90 because it's not at the circumference, that one. So it must be subtended by the diameter on the circumference. Okay, so that is that. Now let's quickly move to the tangents. Okay, those are just two of them left. So tangents from the same point are equal. If two tangents are drawn from the same point outside a circle, they are equal in length, okay? So you have a circle, you have two tangents drawn from the same point. That's tangent number 1, that's tangent number 2, okay? So that's point P. This is A. This is B. That's the circle with center O. So you are given circle with center O and tangents. So you are given circle with center O, and you are given tangent PA and tangent PB. Okay. Then I said to you in the beginning of the lesson that when they say tangent, when you see a tangent, remember tangents, there are three things, even though we haven't covered all of them. The first one is a tangent is always perpendicular to a radius. Okay, so remember that. And then the second one is the one we are proving. Tangents drawn from the same points are equal to the circle. Okay, the other one is from the tan-chord theorem. Angle between a tangent and a chord is equal to the angle on this other segment or alternate segment. We're gonna do that after this one. So there are three things. When they tell you tangent, look out first, look out for tangent and a radius. If there's a radius, we said tangent is always perpendicular to a radius. So this is what you are given. What are you required to prove? You're required to prove that these tangents PB and PA are equal. Then what do you need to do? You need to construct. We said you construct the radius on the time and then extend. That's the radius, that's another radius, but we extend it to P, okay? So now, can you see this is a radius and this is a tangent? That means they form a 90. This is a radius, this is a tangent. We said angle between a tangent and a chord is 90. Tangent is always perpendicular to a radius. So we've got two triangles. Triangle, the minute you have two triangles, that means you might need to use concurrency. So we have triangle AOP, we have triangle BOP, okay? So in those two triangles, let's see, what can we take out? I said to you, there are two things you must look out first, right? Check the radius. The radius must always be equal. They will always be equal. So can you see that AO is equal to BO because radi. Second point, look for a common side. 99% chances are you will have a common side. What is common? Can you see? OP is the wall between you and your neighbor, between the two triangles. So OP is OP on both triangles. Your reason will be common side. Okay, we need one more thing because you need three things to prove a concurrency. So what else is equal? We said angle A. Let's say this is 1 and 2, 1 and 2. A1 is equal to angle B2. I mean, A2 is equal to angle B2. They're 90 degrees. 90 degrees because tangent is always perpendicular to a radius. Can you see now we have a side, and an angle. Therefore, triangle AOP is congruent to triangle BOP. Reason is side angle side angle, sorry. Then we said, once you prove that they are congruent, that means the rest of the sides are equal. Which sides did we miss out? That means this, the rest of the corresponding, this correspond to that. That means AP is equal to PB or BP. This is what they ask us to prove. Okay. So that is that. We have proven that. So whenever you hear the mention of a tangent, whatever is tangent, check. Is there a radius? If there's a radius, that means the angle between that tangents or those tangents and a radius will be 90. And then you check, are those more than one tangent from the same point? If there's two tangents from the same point, that means those tangents will be exactly of the same length. They will be equal. Then the next one will be the tangent between angle between a tangent and a chord. So angle between a tangent and a chord. Okay. Angle between a tangent and a chord are equal. So if they tell you this is a tangent, so angle between a tangent and a chord, you see this is a chord, is equal to the angle on the alternate segment. Remember, I said this is the minor segment, that's the major segment. So the angle between a tangent and a chord, so this angle you see is on this minor segment side. it will be equal to the angle on the alternate segment or the other side. Okay, so those are the three things, but we can quickly look at the theorem for this one. It's the last theorem, then we can do exercises. So you will be given that this is a tangent, PCQ. Okay, so the angle between a tangent and the angle between a tangent to a circle and a chord drawn from the point of contact, that chord must be drawn from the same point of contact where it touches the tangent. Okay, so the angle between a tangent and the chord drawn from the same point of contact is equal to the angle on the alternate segment. So you are given, that PCQ is a tangent, and then with a chord BC, okay, and then point A, and point A is on the major segment. Point A on the major segment. Okay, so you are given those two things. Okay, then now you are required to prove that this angle BCP is equal to angle A, right? Or angle BAC. It doesn't want to write here. That is equal to angle BAC. That's what you're required to prove. Then we said in every proof, the first thing you do is construct a diameter, because there is a center somewhere. I mean, construct a radius, sorry. Why am I confusing you guys? Okay, so we construct the radius here, and then we extend it to that side. Then we join AB, this also. So that's a D. Okay, so you construct a COD and join AD or BD, join BD in this case. Okay, so that's that. We need to prove this. Now, can you see after we have just constructed, when you construct something, you need to be able to pick up a few things from there. Can you see what we have constructed? We can pick up, you see angles on the same side. Can you see angle A is equal to angle D? They are on the same side of the segment. They are subtended by this chord BC. They are equal. So angles on same segment. Okay, so those are equal, right? Then, but can you see that this is a diameter? This COD is actually a diameter because it's joining 2 points passing through the center. If it's a diameter, that means this will be a 90 degrees, right? So that means this is B1 and B2. That means B1 plus B2 will be 90 degrees. Angle in a semicircle. Okay, that's angle in the half circle. Okay, so those are 90 degrees. Okay, then what else can we get? Also, can you see that there is a radius here? If this is a tangent and this is the center, this line is a radius. That means these two will form a 90. Okay, that's a C1 and C2. So C1 plus C2 is a 90 degree. Tangent is always perpendicular to a radius. Okay. Then, because I put my own labels here, I hope I'm not going to have a problem. So I've got those two. I was supposed to work on the other side. Let me see. I'm not on the same side. I was supposed to work this side. Let's cancel this one. Okay, so I was supposed to prove, the way I drew this, then I'm supposed to prove that QCA is equals to So I'm supposed to prove that QCA is equals to CBA. CBA, okay? So I'm proving this is equals to that. Okay, sorry for the confusion. Now I draw things on one side, I use my own labels. Okay, so let's see now. Let's go back. So this is that. Then now let's go back to this one where a tangent. So this one will be C1 and 2. So C1 plus C2, it is 90 degrees because a tangent is always perpendicular to a radius. Okay. Then, but can you see that we did say these are on the same segment, but also can you see that these ones are also on the same segment? They're also equal. So B1 is equals to C2 because those are angles in same segment. Okay. So if B1 is C2 and then these were 90 degrees, we can equate these two equations. B1 plus B2 is C1 plus C2 because they were equal to 90. But we said B1 is C2. So where I have B1, I put C2 plus P2 is equals to C1 and C2. Can you see C1 and C2 and C2 is going to cancel out. I'm left with B2 is equals to C1. And what is B2? B2, it is angle QCB. What is B2? CBA. Okay, so B2 is CBA. And what is C1? Is QCA. Can you see? That's what we were required to prove. Anyone got confused by the mistakes I made? Are you guys all fine? All right, if you are quiet, otherwise, please unmute and ask. It's fine when you just interrupt me. So that theorem just means if you've got something like this, that just means this angle is equal to that. Also, you can look at it from the other side. This will be equal to that. Okay, so it doesn't matter which way you look at it. Okay, so let me give you guys something. I need a bathroom quickly. So I'm gonna give you guys something to do before we tackle an exam question. Or yeah, let me give you guys something to do. Then I'll come back. We can tackle an exam questions. We are given this. That's center O. This is that. And then A, B, C, E, D. Okay, this is 1. And then this is a Y. This is 1. This is X. This is 15 degrees. This is a 30 degrees. Okay, determine the values of X and Y. We want to X, we want to know Y. Okay, in the diagram below, O is the center. So they told you O is the center of the circle, and then DE is a tangent. Okay, so they're asking you to determine X and Y. You need to apply all the information we have learned from the beginning of this lesson. If you see triangles in a triangle, you apply. If you see angles on a straight line, if you see a radius and a tangent, you know they must form 90. If you see theorem 2, you take it out. If you see theorem 4, whatever you see, okay? So please do that. I will be back. Please don't just sit, try it, because you can't be wasting your time here just sitting and then not try. Please try, and then we will do it together shortly when I'm back. I just need a bathroom. Are you guys winning?
I've already found X, but I'm still looking for Y.
Is your X 60?
Yeah.
Okay. Unama, are you winning? All right. What are you winning?
Yes.
Did you get Y?
No, I'm still trying to find why.
You got X to be 60.
Yes.
Okay. Unami? Unami? Are you winning? All right. Let's quickly finish it so we can do an exam paper. Right. So X is, can you see X is the angle at the center, right? And can you see B is the angle at the circumference? So X is twice B. Angle at center is twice angle at circumference. Okay, but B is 30. So that's why your X is 60 degrees. Okay, then they told you that DE is a tangent. I've told you every time they tell you something, there is a reason for it. So they said there's a tangent. First, is there a radius? There are three things I told you about tangent. A tangent is always perpendicular to a radius. And then tangents from the same point, they are equal. Tangent, angle between a tangent and a chord is equal to the angle on the other segment. So what can you see? There's a radius, right? Here is a radius. Here is a tangent. Can you see this will form a 90 degrees? Okay. Then also, besides that one, then also a tangent. Can you see a tan chord theorem? Can you see? This is a tangent and Y is the angle between a tangent and a chord. And this Y will be equal to the angle on the other segment. I don't know where I changed this. Okay. Okay. So this will be angle on the alternate segment. Can you see? If we look at this triangle, at the bigger triangle, that's the angle between a tangent and a chord. That's the one on the alternate segment. Okay. So Y plus A1 plus 15. I mean, Y is equal to A1 plus 15. Okay. That's angle between tangent and chord. Okay. Then we need A1. Then the other thing, we know that X is 60. If X is 60, how much will be A1? So X plus A1 plus C1 is equals to 180 degrees. These are angles of a triangle. But can you see that AO, right? And OC, these are radiuses, right? So AO is equals to CO, that's radii. Then if those two sides are equal, that means their opposite angles are also equal. So C1 is A1. Then that means we can replace them there. So X plus A1 plus another A1 is 180 degrees. Okay, but X we said is is 60 plus 2A1, which is 180. Then we take 60 to the other side, that gives us a 120. We divide by 2, that means A1 is 60 degrees. That's 60 and 60. So you see, A1 is 60. We said Y is what? Y is A1 plus 15. We said that's the angle between tangent and chord. We found A1 to be 60. Therefore, you see Y will be 75 degrees. Okay. So in a nutshell, that is geometry for both grade 11 and 12. So if you go to grade 12, then the syllabus extends to proportionality and the Pythagoras theorem and all that. But this is both the scope for, you will have this very same questions in your exam, whether you're in grade 11 or 12. Okay, now before we go, we answer an exam question. This is the summary of your theorems. You see, theorem 1, line drawn from the center to that's the line from the center perpendicular to a chord. So if that's the case, if you are given something like this, you see, or that line is drawn from the center to the midpoint, that means you will have a 90-degree. Then you can conclude that these angles here, they form 90, okay? That's what you pick up when you see something like that. Then theorem 2, I mean the next one on the right-hand side, you see a line drawn from the center perpendicular to the chord. That means these ones will be equal, okay? They are bisected. Then we go next. Angle at the center is twice angle at the circumference. So this angle is 2 times that one. And also this angle is 2 times that one. And also this angle O2, it will be 2 times that one. Okay? So that's that. Then on this side, chord subtend equal angles. So we said if this chord is equals to that chord, remember, it was on a different sketch, but it's the same logic. So if the chords are equal, the angles that they form, right, will be equal also. You see, F and C will be equal because they are formed by the equal chords. Okay. Then we said when you have a diameter, it will subtend a 90-degree angle at the circumference. The same way when they tell you that the angle is 90, therefore that is a diameter. If they ask you prove that line, whatever is the diameter, check the angle that that line forms at the circumference. If you find that that angle is 90, therefore that line will be a diameter. Okay, so that is that. That's that one. Okay, then next one. How do I get next to the next one? Here's my other picture with the other theorems. Okay, let's close this one. Let's open it here. Okay, here's the other theorems. Okay. You see, if they tell you that these points A, B, C, D are a cyclic quadrilateral, right? That means these angles will be equal, angles on the same side, on the same segment, okay? Or these angles will be equal, okay? Vice versa. If they tell you that these angles are equal, therefore these whole corners, they form a circle. It's a cyclic quad. Or these ones, they tell you these ones are equal. Therefore, A, B, C, D will be a cyclic quad. So we said there are 3 things for cyclic. Either that one, angles on the same side segment are equal, or opposite angles, they form 90. So if you just find a one pair of these opposite angles and they add up to 180, therefore it's a cyclic quad. So then if they tell you that it's a cyclic quad, therefore those angles will add up to 180. If they ask you if it's a cyclic quad, check if those angles, when you add them up after calculating them, do they add up to 180? If they do, therefore it is a cyclic quad. Okay, and then exterior angle of a cyclic quad is equal to the interior opposite angle. So if they tell you this is a cyclic quad, therefore this angle will be equal to that one. Then if they tell you that this angle is equal to this one, therefore this shape is a cyclic quad. Okay, so that's that. Then I didn't take the other picture. The other ones is your chord. Tangents drawn from the same point. So if you've got 2 tangents drawn from the same point, those tangents will be equal up until where they at the point of contact. Okay. Then the last one was a chord. So if you have a tangent, and then a chord from the same point, that angle will be equal to the angle on the alternate segment. So those are your theorems. Now let's go do a question paper. Okay. Right. So let's see. Share my screen. Where's my PDFs? Right. Okay. We're gonna tackle this one. Is from a grade 12 paper, but it doesn't matter. It's all the same. They can even take a grade 11, ask it in grade 12, or they can take a grade 12, ask it in grade 11. It's the same. Right. So let's look at this shape. In the diagram below, TAP is a tangent. So the minute they mention something, you need to ask yourself, what can you get from it? They say TAP is a tangent, right? So put that information down. You're going to need it. TAP is a tangent. Why are they telling you? That means they're giving you something out of it, okay? Then they say AE is parallel. You see the lines, right? So you're going to get something from there. Then they tell you AE is parallel to DC. Remember, when lines are parallel, you have an F shape, Z shape, or U shape. So you check which angles can you take out from that. Is there a Z shape? Is there a F shape? Then you pick out those things, okay? Then they also tell you that DC is, so we're going to get something out of this. They also tell you DC is DE. Where is that? There. Opposite sides equal opposite angles. So if those sides are equal, that means their opposite angles will also be equal. That means we're going to get something out of that. Okay. Then they give you that TAE is 40 degrees and then AEB is 60. Is shown there on the sketch. Now, let's look at the question. Identify two cyclic quadrilateral. I said to you, cyclic quadrilateral is just 4 points. It's a quadrilateral whose 4 points lie on the circle, right? So which quadrilaterals do you see? Kulufela, pick one. Why would you pick another one? Which one do you see, Kulufela?
A, B, C, E.
A, B, C, D. Okay. What would do? Which one do you see? Which four-sided shape that is sitting on a triangle? I mean, that is sitting on a circle, sorry.
DECP.
Okay, so DE, BC. Okay, so those are our cyclic quad, BCDE. Okay, so those are our two cyclic quads. Next question. Determine with reasons the size of the following angles: B2, B1, D. You see the max is 2 marks. That means you're not supposed to be scratching your head for 15 minutes, right? So B2, they want B2. So a trick here, look at the angles that you are already given. Can you see you are already given a 60 degrees, you are already given a 40 degrees. How can you use this 40 to get what, B2? Or how can you use that 60 to get B2? We're doing B2 first. And the information they gave you. Yes.
Can you see that B2 is equals to 40 because interior angles is equal to exterior angles?
Interior angles of a what?
Of a cyclic quad.
Wait, so which cyclic quad? Is it ABCD or BCDE? Okay, not that one, right? So now let's look. Remember, they also said, so when you look at the given values, also look at the statement they gave you, right? They said TAP is a tangent. So if this is a tangent, right? Can you see 40 is formed between a tangent and a chord, right? Can you see that? And can you see that chord subtend that angle? So yes, B2 is 40 degrees, but you need the right reason. Angle between tangent and chord. Does it make sense, Wabudi?
Yes.
Yeah, okay, that's the angle between a tangent and a chord. Okay, so that's that one. We got a B2 to be 40 degrees. So this is 40. right? And then B1. So what is B1? Remember, we are given a 40, we are given a 60, we also got a 40. They also told us that these lines are parallel. And besides, from the tangent that they gave us, we know that B2 is 40. But what else can you pick up from that tangent? Can you see A2 is also, what is A2, Kulufel?
It's 60.
60, the same reason, okay? Because it's angle between a tangent and a chord, okay? Then this is 60. What is A1?
A1 will be, it'll also be, let me see.
How are you gonna get A1? Are you gonna get it with angles in a triangle or angles on a straight line? So whichever one, right? Even though they didn't ask you here for A1, I'm just doing everything in case in an exam they ask you for A1, you will know how to get it, right? So can you see A1 is on a straight line? Can you also see A1 is in this triangle where we already know two other angles? Can you see that? So whichever one you use. So A1 plus E plus B2, 60 plus B2 is 180. That one will be angles of a triangle. A1 plus 60 plus 40 is 180. Therefore, A1 will be 80 degrees. Okay. Even if you do a straight line, it doesn't matter. You're still going to get it right. Okay. So this is 80 degrees. Okay. But let's go back to the question. What else did they need? You see, they wanted B1. B1, what else they gave? They told us this is parallel, right? So B1, where is B1 sitting? Can you see B1 is sitting on the parallel line? And it forms a Z shape, right? Therefore, B1 is how much?
60.
B1 is 60 degrees because alternate angles equal and because line BC is parallel to AE, okay? Then, okay, that's that one. And then now, what else are we left with? Just want to remove this. Angle D. They also told us that DE is, I could see angle D, where is it? It's here. And we were told that this line and that line are equal, right? And if those lines are equal, what can we get from them? That means C1 will be equals to E1, right? But I don't know if it's going to help us now. Maybe not now. It's going to help us in the future. What else did we say? We just calculated B1, right? It's how much? It's 60. Then we said this is a cyclic quad. And what did we say about cyclic quad? Exterior angle of a cyclic quad is equal to interior, but do we have exterior? We don't have, right? No. Remember, exterior needs to be a line extending from the quad itself, right? We don't have that line. We don't have this line extending. We don't have any line of this quad extending, so we can't use exterior. Then what do we have? So we don't have exterior. Opposite angles, right? That's the opposite angle. So you see, D plus 60 degrees is 180. Opposite, interior, opposite angles of a
cyclic quad.
Cyclic quad, okay? They're supplementary. Therefore, D will be 120 degrees. Or but if we are losing you, you must say, ne?
Okay.
So that's 120. Okay. So after getting a D, they want E1. Where's E1? E1 is here. And you see E1 and C1 are equal because this and that are equal, right? So E1 is equals to C1. A reason being opposite sides equal opposite angles. Okay. And then, but we don't know what is E1. Do we know E1? We don't know. We're looking for E1. Do we know C1? We don't know C1, but we can get this. Can you see they're in a triangle, these things? So that means D plus C1 plus E1, they form 180 degrees. D is 120, C1 is E1, right? Plus E1 is equals to 180 degrees, okay? That means we have 120 plus 2 E1, which is 180 degrees. We take 120 that side, that means 2 E1 forms in 60 degrees. Therefore, E1 becomes
30.
30 degrees. Happy, what would it?
Yes.
Right, so that's that. Then let's move on and see what else is here. 8.3. They say, don't want to cancel the whole thing. They say in the diagram below. Oh, okay, we can erase this because it's not part of it. Okay, so this one, in the diagram below, radius CO is produced to bisect chord AB. Okay, radius CO. Okay, so radius CO, sorry, there's a radius, right? Is produced to bisect chord AB. Can you hear that? It's extended this side to bisect. Bisect meaning it's dividing them into two equal, right? So AD is equals to DB. This is a given information because they said radius bisect. Okay. And then if radius bisect, then how much is this angle?
90. 90.
Because a line drawn from the center to the midpoint of the chord bisects that, is perpendicular to that chord. That means angle ODA is 90 degrees. Then if that angle is 90 degrees, that means we can use a Pythagoras, right? They want angle C. So if this is a 90, we can use trigonometric functions, okay? We have a 34. They told us AB is 40. If AB is 40, that means AD is what? Is 20, right?
20.
Okay, so how much is what are we gonna use? What would be, how are we gonna get angle C? We have a 20, we have a 34, we're looking for the angle. We're looking for this. We have this, we have that, and we have a 90 degree. That means you can apply your trig functions. Are we using a sine? Are we using a cos? Are we using a tan?
A sine.
A sine. What would the? Are you familiar with the trig functions?
Yes.
Okay, so we're using a sine because sine is opposite over hypotenuse. So sine C is equals to, our opposite is 20 over 34. Therefore, C will be sine inverse of 20 over 34. Then we get that angle.
Equals 36,03.
So 36,03 degrees. Okay, so that's that. Okay. Then let's move on. We are here. So on this one, they say in the diagram below, O is the center, right, of the circle. So already if they say O is the center of the circle, what can you pick up from just that statement?
That the angle at the center is twice angle at O.
This, the angle at the center is twice this one. So 4x is 2a3. Then what will be a3? Divide by 2. So 2x will be a3. Okay, so this is 2x. Then we read and continue. A, B, C, D is a cyclic quad. A, B, C, D. It's a cyclic quad. Can you see there's a line extending, making it exterior. There's a line extending, making us have an exterior. Can you see we have an exterior? So,
Yes.
okay, so that means from that statement, we know that D2 is B1 and B2, right? Exterior angle of a cyclic quad. Okay, also A1 is equals to C1, C2, C3. Same reason, exterior angle of a cyclic quad. Okay, then let's read and finish. They say BA and CD are produced to intersect at each such that AB is AE is AC. So you see those lines are equal, right? So we will come back to that. So AB is AE is, they also showed them on the sketch, AC, fine. Let's go back to the question. The first one, determine in terms of X, B2. So remember, we said center, you saw angle at the center, but also a center, from a center we get radius, right? Can you see this is a radius?
Yeah.
Can you see this is also a radius, right? That means they are equal. So OC is OB, radi. Okay. So if they are equal, therefore, which angles will be equal? B2.
Angle B and angle C.
B2 and
Angle
C3.
C2.
Okay.
C3.
Because opposite sides equal opposite angles.
Angle.
Right. Okay, so that's that. So B2 and it's B2 is C3, okay? Then, but this is 4x, right? So can you see that now we can say they are in a triangle. 4x plus B2 plus C3 is 180 degrees because those are angles of a triangle. But B2 and C3 are the same thing. What are we looking for? B2. So we're going to change C3 into B2. I get? That means 2B2 is 180 minus 4x. Divide both sides by 2. That means B2 is how much? 90 minus 2x. Okay, so this is 90 minus 2x. This is 90 minus 2x. Okay. Right. Then, so we answered the first one, right? Next question, they want what? E. Angle E. It's a 5 marks, you see. That means we need to do some lot of calculations. Maybe we've already done them. So this is 90 minus x, this is 90 minus x. We also said what? That's 2x. And then, let's see what else. See, they gave us this. Can you see this line? It's equal to this one. Can you see that? So they gave us that AE is AC. Therefore, angle E will be equal to what? C1.
Angle C1.
So opposite, this is given. Opposite sides equal opposite angles. Okay. Right. So E is C1. But how much is C1? How do we get a C1? Just see. C1, C1, C1. Okay, so now, can you also see that the other one, let me see what color I'm gonna use. This, right, is equals to that. Okay, so if AB is AC, therefore, this is given, right? Therefore, C2 and C3 is equals to B1 and B2, right? Are you still with me?
Yes.
Opposite sides equal opposite angles, okay? Then what do we have?
We have C3 and we have B.
So if they are equal, we also have, they are also inside a triangle, right? Remember, normally when you see the angles, then you can add them up because they're inside the triangle. In that triangle, what do we have? We have A3, and we have this C2 and C3, right? We have B1 and B2. Hey, B1 doesn't want to be right in there, okay? They must all give us what? 180. Angles of a triangle, right? I haven't lost anyone.
No.
No.
Okay. Right, so they add up to that. Now, let's see. What is, so we have A3. Let's move this thing out of the way. So, okay, I'm just gonna change the pen to have a clear one. So that's A, this is A3, ne? A3 is 2x, right? How do I hide this thing? Okay, I can't even hide it right now. A3 is 2x, right? And then C2, we don't know. C3 is 90 minus 2, right? All right, let me write it here. So we had A3 plus C2 plus C3 plus B1 and B2, okay, which gave us a 180. We said these are angles of a triangle, okay. Then A3 is a 2x, C2 we don't know yet, C3 is 90 minus 2x, B1 we don't know B1, ne? We didn't calculate B1. B1, B2 is 90 minus 2x. All this must be equals to 180, okay? So can you see that 2x and minus 2x cancel out? I'm left with negative 2x, this one, okay? And then plus C2 plus B1, 90 and 90, they give me 180. These are all equals to 180. Can you see that 180 is gonna cancel out? So I'll have B1 plus C2 to be, I take 2x that side, okay? Then we can say that C2 is 2x minus B1, right? Because we want C2 at the end of the day. But now we need to know what is B1, okay? So that was angles of a triangle. But we also said here, these are equal, opposite sides of equal opposite angles. But we also said C2 plus C3 is equals to B1, B2, right? C2, we don't know, but C3 was 90 minus 2x. B1 is going to take us to the same point, isn't it? B1, we don't know. Okay. And then B2 was 90 minus 2x. Okay. So this will cancel out. Can you see C2 is B1? Then yes. I can take I can put C2 there. That means C2 is 2x minus C2. I bring C2 this side. 2C2 will be 2x. Divide both sides by 2. Therefore, C2 is x. Okay? It's a long one. That's why there's 5 marks there. Is it 5 marks? Okay, 3 marks. Okay, so that's that. So C2 is x. Okay, so this is x. And C1 was what? We don't know C1. All right, fine. Now, next question.
We were looking for
C2. Did we not get E?
we were looking for E when we did this calculation. That's why it's 5 marks. We said
we
that
looking?
we first said that
Oh, we're
E
looking
is
for
equal
E.
to C2 A.
Okay. So, but we already answered question number 3, ne?
Yes.
Okay. So we're looking for E.
Mm.
E. Oh, yeah. We're looking for E. So let's get back to E then. Save here. Then
We said that C2 is equals to E. So that means that E is equals to angle E is equals to X.
where is that? Oh, here. We said E is C1.
No, we said
Huh?
C1. No.
Where is that? Okay, it's fine. I'll start again. But that one was coming from the angle again. So E plus B1 and B2, right?
Mm.
Plus C1, C2, C3. These are angles of a triangle, right? But those two were equal, right? But this and this are equal, isn't it? No, they're not. I'm lying. Okay, they are not, but it's fine. I'm sure we'll get it. So now let's continue. So E is what we're looking for. What is B1? B1 is C2, right?
B1
is C2, okay?
X.
Which is X. What is B2?
90
90
minus
minus 2.
90 minus 2x. C1?
We don't know.
Okay, so plus C1. C2 is X. C3, 90 minus
90
2x.
minus
Okay, let's see what will cancel out. Can you see X plus X and minus will give us a 0, right?
Mm.
And then, can you see 90 plus 90 is 180? It will cancel with this 180, right?
Yes.
We have proven that thing. So, we didn't have to go this way. Can you see, you guys, here? Because this and that were equal. This is exactly where it's taking me. So now, but there's a 2x that is hanging around. So E plus C1 minus 2x is 0. Why do we have extra 2x? E is C1. Do you guys agree that E is C1? Here,
Yes.
opposite sides.
Yes.
Yeah, we didn't have to go all this way.
So E is going to be plus. It's going to be E plus E is minus 2x. Then we take the 2x to the other side, and then E is going
But
to
I think
equals
here we made a
to
mistake. Didn't we make a mistake here? Oh, yes, you are right. We are fine. So, but also at the same time, we know E is C1, right? So that means we have E plus E, right?
Mm.
Minus 2x is 0. So that means 2E is 2x. Then we divide by 2. Therefore, E is,
and E
E is
X.
X. Okay. All right, that was long and yeah. So that's that. Okay. So E is X. Happy?
Yes.
Now, the last question, 9.4. If E is equals to C2, now they're telling you that E is C2, right? Which is X. So we know that this is X also, but this is X. They also tell us that C is X. We also have proven it in our own way anyway, right? If that's the case, they want you to prove that ED is a diameter. Prove that ED is a diameter of circle AED. So they want you to prove that ED, what is ED? ED is a diameter of this circle. Okay, what did I say? If they ask you to prove a diameter, you must look out for 90 degrees, right? Because the angle subtended, and that 90 degrees will always be subtended by the diameter. So which angle are we looking for? A1.
A1.
Right? So we need to check, calculate and see if A1 is not going to give us 90. Okay, so let's look. They are in a triangle, those, or not, even if we don't use a triangle, we don't know D2, right? Mara, you see that, you know that, let's leave D2. This, isn't this equals to this? I get ABCD is a cyclic quad. Exterior angle of a cyclic quad. Can you see?
Oh, yes.
Okay, so A1 is C1, C2, C3. Exterior angle of a cyclic quad. Okay. Why you wanna wabudi? You see it?
No, please explain.
Okay. So I'm just gonna clear everything here so you can see. They said to us that ABCD, this is a cyclic quad, right? This is a cyclic quad. Okay. But can you see this line extend gives us exterior angle, right?
Oh, yes.
That exterior angle is equals to interior opposite. Okay. So A1 is C1, C2, C3. Exterior angle of a cyclic quad. Okay.
Yes.
So A1 is, what is C1? C1 is X, C2 is X, C3 is 90 minus 2X.
90 minus 2.
Now you see X plus X minus 2 is a 0. Therefore, A1 is 90. If A1 is 90, therefore, ED is a diameter. Because remember, a 90 degree should be subtended by a diameter. Happy?
Yes.
Right. Okay.
Yes.
So that's that. Then I think on this question paper, it ended there. Okay. So this is a grade 12. We are not doing that today. So let's see what time we have. Okay, we still have about 40 minutes or so. Let's open a, this was a grade 12 paper. Let's open a grade 11. Okay, here's your grade 11. Where should we start? We'll start here, yeah. Okay, start here. Can you guys try this? Unless if I've given, oh, did I give you this as a homework? I hope not. Did we not do this?
I think we've done this.
We've done this now. Right, we're not gonna do this one then. And then, can you guys prove this quickly? This is 5 marks. You should be able to do this quickly. You see what theorem is this one?
Yes.
So even if, okay, don't prove it, but can you see that's angle at the center twice that? You're gonna construct a radius and then extend it to the side. Then you have 1 and 2. And then you see the minute you extend something, you will have exterior, right? Exterior is sum of the opposite of a triangle. Exterior is sum of those, but you also have what? Can you see? This is a radius. That is a radius. They are equal. Therefore, this will be equal. Same this side. This is a radius. This is a radius. If they are equal, this will be equal. Then you substitute. You get your 5 marks, right?
Yes.
Okay. Then let's go next. Yeah. Don't think this one I had given to you. Right. Now, can you guys do that?
Okay.
So I will give you guys 20. What? Just let me know when you're done. Just send me a picture when you're done. Eh? But I'll give you guys maybe 20 minutes, then we can look through it. So you've got until 11:40. But when you're done, you can send it to me, then I can check for you.
In the background. Oh.
Are you guys winning?
Yeah.
Are you winning, Wabuti?
Which refers to Kuma?
Yes.
11:40.
Okay.
But this shouldn't take too much time. How far are you guys?
I'm in the second question.
Cool fellow, how far are you?
I'm still struggling with the first one.
The first one. Okay. If you guys are struggling here, let's look at it, not waste time. There's still another one here. You see, there's still that one. Which I haven't looked at myself. Okay, let's see. Okay. They say in the diagram. Okay, so in the diagram, O is the center. The minute they tell you O is the center, what do you see? What can you pick up? Cool, Phil. If O is the center, which theorem talks about the center?
The theorem that says the angle at the center is twice the angle at the circumference.
So which angle do you have at the center?
We have O2 and O1.
Okay,
Angle
so
O.
O1 is angle at the center. And which angle is subtended by the same arc which subtend O1 is at the circumference?
A1.
It's A1.
So that means O1 is 2 times 51. So why were you struggling here, Kulfe? 2A1. Angle at center, twice angle at circumference. That means O1 is 2 times 51, which is 102 degrees. Okay, done. You see, that's 2 minutes, so it's 2 marks. Then next question, they want what? A2. So let's read and finish because we didn't finish reading. Points A, B, C, and D lie on the circumference. I said if the points lie on the circumference, it means they form a what?
A 90-degree.
A cyclic quad. So points A, B, C, D lie on the circumference. That means they form a cyclic quadrilateral. You see? So if that thing is a cyclic quad, there are 3 conditions, right? You check which one is here. The first one was this one. If you've got this, right? These angles are equal. Tell me which one you have. Or you have this one where there's an extended, which makes an exterior. Or there is this one where now the opposite angles add up to 180. So which one is it? Do you guys see here?
See the first one where angle D is equals to angle C.
So angle D is C1 and C2, ne? Angles on the same segment. Which other one? Can you see also A2 is what? Is B2. Okay, angle on same segment. Okay, right. Then what do they want? A2. Okay, we want A2. So
A2 is
A2.
30.
Can you see where A2 is? Can you see A2 is sitting on a radius?
Yes.
B2, I mean, not A2. Can you see B2 is sitting on a radius? So they said it's a BOD is the center, right? Okay, before we go far,
It's the
they said
diameter.
this is a diameter. BOD is a diameter, right? So that means they subtend what angle?
90.
90.
degrees.
That means A1 plus A2 is 90 degrees, but A1 is 51. Therefore, A2 is how much?
29.
29 or 39? 39.
39.
Okay, so that's 39. And we said B2 is A2. Can you see, therefore, B2 is also 39? So this is 39. That means even this is 39. Okay. So that's that one. What do they want? Oh, we answered A2. So that is answered, right? So we answered this, we answered that. Now, they want what? D. And if this is 39, you see, even this will be 39 because
Yes.
the radius is there. Right, D, okay? So they want D. Where is D? Can you see D is inside a triangle?
Yes.
It's inside this triangle. And in that triangle, we have a 90 degrees, we have a 29. So D plus A1 and A2 plus B1 is 180. Angles of a triangle, right? D we don't know. A1 and A2 is 90 degrees plus B1, which is 29, right? It's 180. Therefore, D is 180 minus 90 minus 29. And this is how much? 50?
61.
61. Okay, happy?
Yeah.
Yes.
Okay, then what else do they want? Determine the size
size
of
of
ACO. What is ACO? Let's see where that is. It's pink. Where's A? ACO. That's a C1, right? So how do we get that one? You see, it's inside the triangle, that C1, this big one. So 51 plus the C1 and C2, ne? Plus B1 and B2, right? They must give us 180 because angles of a triangle, right? 51 plus C1 we don't know, C2 is 39, B2 is 39, B1 is 29, which is 180. How much is that? So 180, so 51 plus 39 plus 39 plus 29, which is 158 minus from that. C1, I get 22.
22.
Okay, see, that's done. So you need to look at what you are given, right? So first, look at what you are given. They told you that's the center. Then center, you know, you can get angle at the center being twice the one at the circumference. You also know center, you get radiuses, which will be equal. That means these two will be equal. Then they say points are on the circumference. That means if they are on the circumference, they form a cyclic quad. That means you can take out these angles being equal. You can take out these ones being equal. They say to you, BOD is a diameter. That means if this is a diameter, that means that must be 90 degrees. Okay? And then when you start answering, always try to check which values are you given? If you are given 51 and 29, see if in one step you can actually get the answer from the first question, right? Especially if it's a 2-mark. Because if you see here, you see we have a 51, we have a 29, they want O1. Check, can you relate O1 and B1? No. Can you write O1 and 51? Yes. Then you pick that up, okay? Then they want A2. A2 is here. Can you relate A2 with the information you already have? Okay, so you do that. If it's not straight away, you check the other things that they gave them to you. They gave you a diameter. That means there, you add them up, they give you 90 degrees. Okay. Right, let's move on. Yes, that one. Okay. So here, this one, I haven't done it myself because the other ones I had prepared them in the morning. So here they say, in the diagram, O is the center, okay? So check if O is the center, what are you gonna get? Sometimes maybe you won't get anything, but sometimes you get something. So O is the center, right? I don't see angle at the center and at the circumference on this one. Subtended by the same thing. They are. Let's see, I'm seeing something. So can you see if this is the center? You see this is at the center. But what else subtend? The same thing subtend at the circumference. There, this one. Can you see? Can you see they are subtended by the same arc? Right? Am I right? I hope I am. Can you guys see that? That's
Oh, yeah.
CT. It forms this angle at the center. The very CT forms that angle at the circumference, right?
Yes.
Yeah, but I'm not sure if it's gonna. I'm not sure if it's gonna help us, but we can put it down. O2 is 2 times A2 and A3, right? Angle at center, angle at the circumference. Okay. Is twice angle at circumference. Okay, let's leave it. That's the only thing I see, but there's also radius. Can you see the radius? Because this is the center.
Yeah.
This is a radius.
OC,
That's a radius. These are
OA,
equal. That means now if OC is equal to OA, which is a radii, that means A2 and A3, they are equal to C1. Can you see this angle and that angle? Right?
OT, radius.
OT, yes, but it won't help us. But the only thing is then it will only give us a diameter, which at the moment is not really going to help us. Because you see, if OT, it is a radius, but how is it going to help us? You see, that's a radius, that's a radius. It's not really going to help us. Okay? Yeah, okay. So that's what I can see at the moment. Then,
As tangents from the same
they
point.
tell you HT and HC are tangents from the same point. Can you see they are tangents from the same point? Remember the theorem here, tangents from the same point. Those tangents will be equal. That means HC is equal to HT. Tangents from same point. Okay? They're equal. But that's not going to help us because you see there are no angles that we can equate them to. But remember tangents, we've got 3 things on tangents, right? Tangents from the same point are equal. Tangent is always perpendicular to a radius, and then an angle between a tangent and a chord. Can you see now? That's a tangent and that's a radius. This is a tangent, this is a radius, right? That angle is 90. So T is 90 degrees. Tangent perpendicular to a radius. Also, can you see that? This is a radius, that's a tangent, right? This angle will be, so
90.
C2 plus C3 is equals to 90 because tangent is perpendicular to a radius. But you see C2 is a X. That means
C3 is
C2,
X.
yeah, C3 is X. So this is 90 minus X. Okay. So, okay, so that's that. Then what else did they tell us? AD is produced to meet AT at R, OC bisects AD. So these lines are equal, right? Okay, at the moment, I'm not sure how it's gonna help us, but I'm sure somewhere it would. Then, if it bisects, yes. So you see, they said
9.
O, what bisects that? OC, ne? It bisects this. You see theorem, converse of theorem 1. Can you see it? Because this is the center, line from center to the midpoint. Therefore, those angles will be 90 degrees.
90.
So OC, if OC bisect AR, that means J1 is J4, which is 90 degrees.
And
Okay.
then isn't J
2 and 3,
equals to J4?
they also 90. Okay.
Okay.
So J1, J2, J3, J4, they are all 90 degrees. J2, J3, they are all 90 degrees because a line from center to midpoint. Okay. Okay, so that's all the given information. Okay, let's go to the questions. Let's just say you have put this on the side, right? On your scribbling paper or something, this information. You can pick it up, put it where it's necessary. Question 1, write down with a reason another angle which is equals to C3. Can you see C3 is the angle between what? A tangent and a chord. Can you see? They said this thing is a tangent, right? Can you see this is the chord? Remember, a chord is just a line joining 2 points on the circumference without passing the center. That's angle between tangent and a chord. It's going to be equal to which angle? On the angle on the alternate segment. So C2 is equals to C3, I mean,
A
is equals to A2, which is X. Okay. Sorry. Can you give a reason? Angle between tangent and a chord. Okay. Then question 2. Show that CHRJ is a trapezium. CHRJ is a trapezium. Remember, what is a trapezium? Is that quadrilateral with only one pair of opposite sides parallel, right? Right? That's a trapezium, if I remember correctly. Only the sides. This is a trapezium. Okay. So for us to prove that this is a trapezium, that means we need to prove the two sides of that shape to be parallel. Okay. So it's either we're gonna prove that CH is parallel to JR or CJ is parallel to HR, right? So either we're gonna prove that CH is parallel to JR or CJ would be parallel to HR. Remember, it's just one side. So for us to know that if lines are parallel, remember, we need their angles. Either you will find maybe their corresponding angles are equal, or their alternate angles are equal, or their co-interior angles are supplementary, right? So we need to look out. What shape is there? You see, we have a Z shape. You see that Z shape. So if we can prove that D1 and D2 is equal to that angle, then those lines would be parallel, isn't it?
I see co-interior.
You see co-interior.
And we did say that angle C is angle C 3 and 2 is 90, and we said that angle J3 is 90. So that means that they are
So this is 90. So let me do this. Let me use another color. Which one am I going to use? So this is 90, right?
Mm.
From here, where is it? I didn't write it. J, okay, I didn't write it. So, but you remember you need to write them again when you put them down. So we're gonna say, oh yes, here. So you're gonna say J3 is 90 degrees because line from center to midpoint, right? So J3 is 90. Also, we know that C2 and C3 are 90 degrees because tangent is perpendicular to radius. What you still with us, right?
Yes.
Okay, so that's a 90. Okay, and then, but those are not a, oh yes, that's co-interior. Okay, so those two angles are co-interior. So when we add J3 plus C2 and C3, what do they give us? 90 plus 90,
100.
which is 180. Therefore, these are co-interior angles, which are supplementary. Therefore, line CH is parallel to GR.
9.
Right? Happy, what would it?
Yes.
Okay, so that's that. I was not even gonna see that way. I don't know where I was going. Okay, so that's that. And okay, so that's that one. So C2 is that, those two, yeah, it's fine. I'm just looking if there's another way to do it. Number 11.3. Prove that, so if those are parallel, therefore it's a trapezium. I guess don't forget to say that. Therefore, that CHRJ is a trapezium. Okay, because one pair of opposite sides parallel. Right. Now they say prove that OC bisect ACD. Prove that OC, where's OC? OC bisect ACD. Remember, when something bisect, it means it divides them into two equal pieces. That means we need to prove that C1 is C2, right? Agree?
Hello.
Yes. Are you guys still with me?
Yes.
Yes.
Okay, so that's what we need to prove. So let's see. What is C1? What is C2? Let's find out if they're not equal. Okay. So just checking, I'm just checking. How many marks? 3 marks. Okay. What do you guys see? What are you guys seeing? That's a 90. Okay. If these lines are parallel, right?
What are we checking?
We're checking if C1 and C2 will be equal. Remember, they said we are proving that, you see at the bottom, we are proving that, let's wait. Let me pull this a little bit up. Come now. We are proving that, okay, I don't want to hide the sketch. We're proving that OC bisect angle ACD. So we are proving that this bisects this angle. That means when it bisects it, that means C1 will be equal to C2, right? Yeah, that's what we're proving, okay? We have already proven that this line is parallel to that, right? Because we proved the trapezium, right?
Mm.
And if that line is parallel to that, we can get some angles to be equal. So D1 and D2 will be X. Can you see that?
Mm.
Is X, because those are alternate angles. See what? What is that thing at the top? Parallel to JR. CH, I think. Okay. Then, so this is X. And then C2, what is C2? This was 90. You see C2 is 90 minus X.
Yes.
So C2 plus C3 is 90 degrees because tangent was perpendicular to radius, right? But C3 is an X. That means C2 is 90 minus X, okay? Then we need to get C1. Let's see C1. How are we gonna get C1? C1 is A2 and A3, right? This and that are equal. C1 is A2 plus A3, right?
Mm.
Because OC is OA. Opposite sides equal opposite angles, okay? Which angle was C3 again?
C3.
It was A2, isn't it? It was A2, right? Which is X.
Mm.
So this is X, okay? So that means C1 is A2 plus X, okay? Then now, let's see. Can you see that this triangle, all these angles we are talking about, can you see this big triangle, the green triangle that I just highlighted, right?
Mm.
In that big triangle, if I divide it here, you see those, it becomes like this, right? We were given these are equal already. Can you see? This is a common side,
Oh, yes.
right?
Mm.
And these are 90 degrees. Can you see these triangles are congruent?
Mm.
And if they are congruent, therefore, this side will be equal to that side. And if they are equal, that means this angle will be equal to that angle, right?
Mm.
Okay, I'm going to do a shortcut. You guys, you can do it alone and just make sure. So that means actually A2 is X. Is it X?
Yes.
Not A2, yeah, it's X because this is that. Because A2 is D1 and D2, okay? But D1 and D2 are X. So A2 is X. That means C1 is 2X, okay?
Mm.
But
Yes.
it doesn't solve our problem. Because now if C1 is 2X and C2 is 90 minus, that's not the same. Okay, so what else is there?
If we prove congruency, then we said that the sides are equal. So they subtend equal angles.
Oh, okay. Maybe we might have made a mistake here. Let's leave this one for now. So let's leave that one out for now. If now we take the congruency, can you see? If this one is equal to that, right? It means those are equal. That means even this will be equal to that, right? C1 will be equal to C2. right?
Mm.
Am I not right by saying that? I think I am.
You're right.
Okay, but let's check. Let's just double check our answer. I see the time is gone now. Oh, not there. Now let's change this. This is question 11. It was 11 point what? There.
The last one.
Yes, yes, it's exactly that. You see congruency. You see they use congruence. 11.3, yeah. Okay, so that's that. Right. Okay, so that's that. Then the next one. Write down with a reason angle ABD in terms of X. Where is ABD?
A, B, D. Angle B.
Angle B, right? They want it in terms of X. Okay. Okay, let's see. And can you see? That's an angle on the same. Can you see that that angle is on the same side with this one?
Mm.
Can you see that this, they're on the same side? You see they are subtended by this, is that, and also that, right?
Mm.
Can you see? So angle B is equals to C1 plus C2. And then C1, we just proven C1 is equals to C2, right?
Yes.
So C1. And how much was that? What was C1?
It was C1
No,
was
no.
2x.
It
Was
was
it 2x
8.
or was it X?
2x. Huh? Yeah.
This was 90.
C1 was 2x because we said that A2 plus x, which is the same. Yeah.
Was it 2x?
Mm.
Okay, hope so. Let's see. Then that means B is 4x. Can you see?
Mm.
Okay. Then determine R2 in terms of X. Where's R2?
On the tangent.
Okay, let's move this a little bit. So R2, you want this, okay? On the tangent, but it's not really helping whether it's on a tangent because, so what else did they give us? Also, what do you guys see here? How many marks is that thing? Bible. 6 marks. Okay, that's a long calculation. Let's check the memo because I don't have time anymore. Eleven. What was that? B1 and C1 and C2, ne? What was C1? C1 is C2, but we didn't get the value. C2, wasn't C2 90 minus X?
What?
C2 was 90 minus X. Right? There is C2.
We said, when we said A1.
Yeah, but C2, remember this is 90, right? You see C2
It
will
was,
be.
but you've written A2.
Then now we said, because these are congruent, right? We said this one is equal to this, and we said these are equal. Then just by congruency, C1 is C2, but C2, it is 90 minus X, right? Then they wanted what now? They wanted, what was that angle that we were solving? Oh, C, the whole angle C, right? So C1 plus C2 is 90 minus X plus 90 minus X, right? Which is 180 minus 2X, isn't it? I agree they wanted AB what? AC something. Okay, right. Then now the new question now they were asking us to find this, right? R2. Okay, so this is 90, that's 90. And if these are parallel, this is X. And then, Aibo, it doesn't even need a lot of, oh, okay, no, these lines are not parallel. It's only these ones. So can you see H is R1? Because I get we said these lines are parallel. Can you see? Are you guys still there?
Yes.
So R1 is H because the lines are parallel. And okay, let's look at that thingy because now my brain is looking at the time. I need to do other things. Let's see. T is 90. Where is T? Yes, this is 90. Yes, remember this one. This is 90 because tangent and radius, right? I think then now we have the answer. Let's clear here. Okay, so this is 90, right? This is 90. Can you see? You see those, what are those? Opposite angles of a cyclic quad. T is 90 degrees. Where? Because a tangent is perpendicular to radius, right? But also we know that J4 is 90. This was proven, right? Then if these opposite angles are 90, so if they add up to, which is 90 plus 90, they add up to 180. Can you see therefore that means T, T, J, O, T, TR, right? It's a cyclic quad, right? Because they add up to, the opposite angles add up to 180. Then if this is a cyclic quad, can you see? Then that means this will be equal to that. Exterior angle, can you see? Exterior angle of a cyclic quad. If this is a cyclic quad, then R2 is a O2. Exterior angle of a cyclic quad. Okay. So, but now what is O2? Did we get O2 at some point?
It's 9. O2 is
Okay. So R2 is O2. So we need to find O2. What can be O2? A2 is at the center. And then this way equal, because this is the radius, right? That can give us O1. So can you see O1 plus 2C1 is 1/8, right? And you see that? I get it. C1 is equals to C2 plus C3, right? I mean A. Can you see that? Because opposite sides equal opposite angles, right? Are you guys still with me? Then
Yeah.
I'm adding the angles in a triangle. So which is O1 plus C1 and A2 plus that, but C1 is that angle. So O1 plus 2C1. Therefore, O1 is what? Is 180 minus 2C1. Didn't we get a C1 somewhere?
we got C1 as 90 minus X, I think.
C1 is 90 minus X.
Mm.
90 minus X. Let's just check. Okay. C1, yes. C1 is C2, right? Which is 90 minus X. Okay. So now let's calculate and finish. That means I have 180 minus 180 plus 2x. You see, O1 is 2x. If O1 is 2x, therefore what is O2? 180 minus?
Oh,
Because they're angles on a straight line. Right?
180 minus
2x, right? Because O1 is 2x. Right? Therefore, what is R2? We said R2 is O2. That means R2 is 180 minus 2x. Is that what they were looking for?
Yeah.
So, let's see if we are right. Let's check. Yes. Okay. Right. Then that's it. Happiness. Are you guys okay?
Yeah.
Right. So now you should go and try a different question paper from the ones we did. Then you are ready to write any exam on this section. Okay. So I can send you guys a homework. I can just pick a question paper, then send you guys a homework so you guys can do that just to make sure that then you are covered. Then even when you are doing this section, then we just do a revision if we haven't done it. Otherwise, you just get ready for your test or your exam when you do this section. So should I send you guys a homework on this? You guys want the homework or not? Hello. I didn't have homework. You guys don't want the homework. Eh? Well, I can't hear you guys.
Yes.
Eh? You want or you don't want?
You want the homework?
Okay. What would it? Should I send you? Just to make sure that we didn't waste time today. So that
Yeah,
you
you can send the homework.
All right. Yeah, you were not.
We do.
Okay.
I
all right.
do on my side.
Okay. What would you? Should I send you also?
Yeah.
All right. Okay. Sharp. Then Yeah, I'll see you guys when I see you on weekend. Ne? Bye-bye. Sharp.